Hello, this is the first video in a series of videos that I've created on the topic alcohols. In this particular video, we're going to only be looking at some of the fundamental concepts behind alcohols. And in the following set of videos, we'll look into some of the chemical properties and uses of alcohols. So before we progress any further, we need to know what is the general formula of an alcohol. Alcohols have a general formula CnH2n plus 1OH. If you think about it, it's quite similar to CnH2n plus 2. So CnH2n plus 2 is the general formula of an alkane. So if we take that as methane, all you have to do is remove one hydrogen and it becomes CH3. So that is your alkyl group. And if you replace it with OH, that becomes your alcohol. So what we've effectively done is taken one hydrogen out, and that becomes 2n plus 1, and replace that hydrogen with the OH functional group. You can classify alcohols into primary, secondary, or tertiary alcohol, depending on how many carbon atoms are attached to the carbon that's attached to the OH. So that's important to understand, that we're only focusing on the carbon that is attached to the OH functional group. So if the carbon that is attached to the OH functional group, if that carbon is attached to at least one carbon or non-carbon. Yeah, so it's not necessary that this particular carbon has to be attached to a carbon, or if it's attached to a carbon, it's just one more carbon, then we say that that alcohol is a primary alcohol. If this carbon is attached to just one more carbon, then it's primary. If it is attached to two carbons, so this is carbon 1, this is carbon 2, then it becomes secondary or 2-degree alcohol. If this carbon is attached to 3 different carbons, then it's an example of a tertiary alcohol or 3-degree alcohol. So if we give them names or do a formula, so this could be it, CH3, CH2OH. So this is CH3, CH2OH. So this is your 1-degree alcohol, which is ethanol. This could be CH3, CH3, COH. So what we've effectively done is CH3, then you've got CH3, so this is CHOH, CH3. So this is 2-all. So I've got 1, 2, 3. So this becomes 3 carbon, that's prop, all single bond, and 2-all. So you can already see that the general name is alkanol, and the all indicates the functional group. This could be CH3, the tertiary, CH3, CH3. So what we've written is CH3, COH, and then you've got another CH3 here, another CH3 here. So it's another way of just showing the compound. So 3 carbons in the longer chain, so that parent chain is prop-N and position is 2-all. So in that concept is quite similar to that, the secondary alcohol that I've shown here, but on position 2 you've also got a methyl group. So this is 2-methylpropane 2-all, which is an example of a 3-degree alcohol. And it's quite important to understand the meaning of these 3 different classification or the categories of alcohol, because based on the 1-degree, 2-degree, 3-degree, you will have to oxidize and carry out some reactions. So it's quite important to differentiate between them. So moving on, we're going to look into some of the physical properties of alcohol. So the first property we're going to look into is the boiling point. Now the point to remember, if this comes up as an exam question, you've always got to think about, in questions based on boiling point, you've got to think about what is the structure of the compound, what is the bonding in the compound. So you've got to think about the structure and bonding. You've got to think about the intermolecular forces. If the intermolecular forces strong or are they weak? If they are strong, common examples of strong intermolecular forces are hydrogen bonding. So hydrogen bonding would be a strong intermolecular force, weak would be van der Waals forces, or London forces. So strong intermolecular forces would lead to more energy needed to break. More energy is needed to break the intermolecular force, therefore boiling point or melting point is very high. So that's your kind of a rubric, a structure that you need to follow in order to answer questions on boiling point. So let's use the same structure to find out the boiling point or predict what sort of boiling points would alcohol have. Now alcohol structure, if I may, so I've got, if I just use this as an example, so that's your methanol. Methanol, oxygen has got a lone pair of electrons, so that is highly electronegative. So remember that FON elements, FON, so fluorine, oxygen, nitrogen, these are highly electronegative elements, and therefore if they come in contact with or they are closer to a hydrogen in another compound or in another molecule, they will form a very strong bond which is called hydrogen bond. So if you look at alcohol, it has got the FON element, it's got oxygen and it's got hydrogen as well. So if I place another alcohol molecule, another methanol molecule close to it, it also has the same polarity. So you've got partially positive hydrogen and very highly electronegative oxygen. So the charge difference is high, and between the positive and negative there is this strong force of attraction, and this force of attraction is called hydrogen bond. So the hydrogen bonds are formed between methanol and methanol. So if you have to boil this alcohol, you will have to provide extra amount of heat to break the very strong intermolecular forces of attraction, and therefore the melting and boiling point is very high. So when you look at the structure, the bonding is covalent bonds in between within the molecule, and in between the two different molecules the force of attraction is hydrogen bonding. So the boiling point of alcohols would be higher. Now, when I say higher, we're going to compare it to alkanes. Now, what sort of boiling points would alkanes have? Alkane is, let's take an example, CH4. So CH4 has got carbon and hydrogen bond. Carbon and hydrogen have similar electronegativity, so the bonds are non-polar. So straight away you know these are covalent bonds, so structure is simple molecular. When we look into the intermolecular forces, we know the structure is non-polar, therefore it will not have any of the hydrogen bonds or permanent dipole-dipole attraction. The only force of attraction in this case is a very weak London forces, and therefore the boiling point of alkanes is going to be low. So it will have low boiling point. So compared to alcohol, alkanes will boil off at a much lower temperature. What about the volatile nature of alcohol and alkanes? So alcohol and alkanes, you can compare the volatile nature by just remembering that what the link between their volatile nature and the boiling point. So if you look at what is meant by volatile, volatile indicates how easily a compound or a material is converted from a liquid state to a gas, from a liquid to a gas. So the clue is higher the boiling point, lower is the volatility. So we've got alcohol and we've got alkanes. In the previous one, we looked at the example of methanol and methane. We said alcohol has got hydrogen bonding, and because it's got hydrogen bonding, its boiling point is high. These alkanes have got London forces or van der Waals forces, therefore it has got low boiling point. So automatically it is clear that alcohols have lower volatility than alkanes, provided they have the same number of carbon atoms. What about the solubility in water? So again, when you do solubility, you've got to look into the forces of attraction between that alcohol and water. So again, the same concept applies. You've got to look into the foam elements and then see, will there be hydrogen bonding between the oxygen and the hydrogen of alcohol and hydrogen of water, or hydrogen of alcohol and oxygen of water, and you will find that there is hydrogen bonding here. So therefore alcohols will be water soluble because they can form hydrogen bonding. What about alkanes? Will they be soluble in water? Alkanes do not have the foam elements, therefore they cannot form hydrogen bond with water, therefore alcohols will be insoluble in water because they are non-polar. And that's why we use the term like dissolves like. So polar materials will dissolve in polar solvents like water. When we compare the physical properties of alkanes and alcohols, it's interesting to note that if the carbon atoms are the same, there's a stark difference in the boiling point initially, but as the number of carbon atoms increases, the boiling point of alcohol, which should have increased in that way, it's actually plateaued out. So what is happening as the number of carbon atoms increase? So if that's the oxygen there, as I increase the carbon chain, this part of the molecule is the one that forms hydrogen bonding with water. It's important to note that as the carbon chain increases, the contribution of the OH group decreases, and then the alcohol will resemble an alkane more closely. So higher the number of carbon atoms, you will find that it starts to resemble in its physical properties to that of an alkane. So far what we've covered is we've looked into the general formula of alcohols. We've looked into the classification of alcohols, which is extremely important if you're going to study about the oxidation reactions of alcohols, because primary, secondary, and tertiary, they all behave differently. Then we've looked into some depth at the physical properties of alcohols. And a point to remember here is, whenever you look into physical properties, you've got to think about the structure, the bonding, and the intermolecular forces. And then we had to wrap it up, compared alcohols with alkanes. Thank you for listening.